All right, so we are on to our last test for chi-squareds, which is the association and independence. Okay, association or independence. Okay, so previous ones we're looking at trying to see if the data fit a certain distribution. We also wanted to see if the a distribution was similar between different populations. That was the last one we did on homogeneity. And now this one is testing to see if there is an association or not between the different categories. Okay, so if there's a tie-in between it. So chi-squared test of association / independence. Okay, very similar to the homogeneity. It's basically the exact same process for everything. The only difference here is that you use a different question. Okay, same formula, but it's just a different question. Your HO and HA, your null and alternatives, are going to be asking that there is no association between two variables. Okay, that is your null, and your alternative is that there is an association between the two variables. Okay, so that is the main difference here, is that you're asking is there association, compared to homogeneity, which is asking about is there there is no difference between the distribution of the categorical of the data between the populations and the treatments, or that there is a difference. Okay, so that was the homogeneity, is that there is a difference between the parameters essentially and the distributions. This one is asking, is there association between them? So is there a connection to them? If there is no association, that means that the two variables or the two categories are completely independent of each other. As one changes, the other one does not change. When we usually have things that we're looking at, for the most part, they're probably not going to be associated anyway. They're probably going to be disconnected. Okay, an example of something that might be connected or there might be association with is if, let's say, you have two people playing tennis with each other, and as they're playing tennis with each other, one is better once they warm up. So there would be an association between them playing with no practice compared to them with practice. One person's going to win more often if there's more practice, because they're better once they get warmed up. Okay, there's an association there. Okay, so that would be an example of something with an association. But this test is to see, are they independent or are they associated? Okay. So another way that you can write your null and alternative hypotheses is to state that they are independent or not. Okay. Now, in the previous one, when you are saying if you're using association, the null hypothesis is that there is no association. Okay. So there's no association, while the alternative is that there is an association. If you use independent, the null is that they are independent, and the association and the alternative is that they are not independent. Okay, so you see how it's kind of switched there. Okay. So just be careful. What I would do is I would pick one and always use that. So always use independent or always use association. Don't try to move back and forth between the two. Okay, so pick one and then continue. Again, it's very similar to the homogeneity method, or the test for it. The conditions for both must be the same. You have to have the larger than 5 expected. Expected counts process is the same formula. Chi-squared test statistic is the same. Degree of freedom is the same. P-value is the same. Everything is the same. Again, the only thing that changes is in your state and your conclude, because it's the question that you're asking. This test is asking about independence and association, not if the distributions are similar. Now, here would be an example of one that you have. So there's an observed and an expected one that's empty. If you see this on like the AP exam, they'd expect you to fill out that other table. okay, because they'd probably look at that for your expected. And again, you can use your calculator for that. If you want to use the matrix stuff, you can use the matrix to help you find the expected, or you can try to do it by hand. Again, whichever one you are more efficient in, you can use. So this one's looking at people with blood pressure, normal blood pressure, and then ones with heart disease, etc., etc. Is there a connection between that with people who get angry suddenly, yada yada yada. Okay, and so we have this, but you see down at the bottom the words that's highlighted down there is that it's asking specifically about an association. So if it's asking specifically about an association, then you know which test you're going to use. You are going to use your chi-squared test of association / independence. Or if they mention about are the two categories independent of each other. So those are your key words that you're looking for, okay, for this one. Okay, so underneath our state, I'm going to use the word association because why not? So we would say there is no association between anger level and heart disease. Okay? And then the alternative is that there is an association, so there is a connection. Okay. Now, if you want to use the word independent on this, okay, it would be there. It would be that the two categories are independent of each other. So anger level and heart disease are independent of each other, while the alternative is that anger level and heart disease are not independent of each other. So that just depends on which one you'd rather do. Okay, so plan. Again, state which chi-squared test you're using, chi-squared test for association or for independence, whichever one you choose to use. Check to make sure they're all larger than 5. So again, you take the grand total of the column multiplied by the grand total of the row, and then divide it by the grand total of everything, and that gets you each one. Okay. And again, just like the previous one, same process. So there's your plan. You write it out. You don't have to write them all out. Again, 3 with the ... should get you there. Degree of freedom. So there was 2 rows. 2 rows, and there were 3 columns. So 2 minus 1 is 2. 3 minus 2 is 2. So 2 times 1, or 2 minus 1 is 1. 3 minus 1 is 2. So it gets you 2. Chi-squared is 16. And then the p-value, there should be a negative there. The p-value is 3.23 times 10 to the negative 4th, not the positive 4th. So it's an extremely small number. So because it is an extremely small number, we would reject it. We have convincing evidence that there is an association between anger level and heart disease with people with normal blood pressure. Okay, so we would say that there is an association between those two because of the such a low p-value. And as you notice, there is no alpha here, so you're making a judgment. But for the most part, it's going to be way on one side or way on the other. It's not going to be kind of in between. Okay. All right. So when you are choosing which test to use of your chi-squareds, okay. So again, remember if it's one independent random sample with multiple different categories, then you're using the goodness of fit test. Okay. So example of this would be if you have a bag of M&Ms and you take the M&Ms and want to find are they distributed a certain way. Okay. Goodness of fit test, GOF, which you can abbreviate. If you're looking at data that is 2 or more independent, random sample treatment, yada yada yada, random experiment, then you're looking for the chi-squared test of homogeneity, which is again the example we did about if you play Italian or French music, does it change? So you've got 2 or more different independent samples and treatment groups going on there. And the last one, which is the association, which we just went over, and that is basically to use to see is there a connection between 2 different categories. So is there a connection between them or is there not? Are they independent of each other or is there an association? Okay. So you just have to read through and you have to say, okay, it's this one or that one. Look for keywords in them. Again, the last one, you're looking for association or different or independence of it. Okay, if you're looking at the distributions, you're looking at the first one, etc. Okay, so fairly straightforward, fairly easy. The next section is basically a review. You'll be getting a sheet that has everything that's going to kind of go over, and you'll have to complete the sheet. Okay, and that is it for section 4, or section 3 of unit 8, which basically puts an end to 8, which means all we have left is unit